folks, we have made it to the end of the chapter. This is Geometry, Chapter 2, Section 8, Proving Angle Relationships. And up first we have a couple of postulates. Remember that postulates are basically things that we do not need to prove, things that we just take on faith, so to speak. So we have the last section, we had the ruler postulate, which basically told us that we could measure segments, and in a similar fashion we have the protractor postulate. It gets kind of wordy, but just want to remind you that basically it enables us to measure angles with this little device, protractor. So it says, given any angle, the measure can be put into one-to-one correspondence with the real numbers between 0 and 180, which basically means that like a ruler, we can start right about here, and any number between 0 and 180 that exists can also be found on our protractor. That means that we could have things like obviously 10, 20, 30, but also 35, 31.2, and on. Any number between 0 and 180, all the way across here. So basically it allows us to measure angles. All right, and then of course, like the last section, we had the segment addition postulate, which basically stated that if you took a segment and broke it up into 2 or more pieces, that you could add each of those individual pieces and then you would equal the whole. That's kind of the same idea with the angle addition postulate, although because it's an angle, some students do have a harder time visualizing it, so I hope that my diagram makes sense. But here it goes. It says D, and point D is right over here. D is in the interior, so inside of angle ABC. So here's angle ABC, and D's on the inside. D's not out here somewhere, it's on the inside of the angle. This is true, my bad. This is true if and only if the measurement of angle ABD, so what I've done here is color-coded it with red. So here's ABD, so that's basically this piece right here in red is X degrees. Added to the measurement of DBC, which is this guy here, the blue, then that equals the entire measurement here. So basically it's the same idea as it is with segment addition postulate, that if I take an angle and if I cut that angle into more than one piece, in this case primarily these 2 pieces, that if I add those 2 pieces together, it will equal the whole angle itself. That's kind of what that guy means there. So we are going to start with our examples. If I can get my pen to get on here, let's see. Nope, not yet. There we go. Okay, so here we have example 1. Find the measurement of angle 1 if the measurement of angle 2 equals 56 and the measurement of JKL equals 145. So what we want to gather from this diagram is that you have the angle from J to K to L, which includes all of this, and there's 2 pieces. So what we know is that if I take the measurement of angle 1, that would be this piece here, and add it to the second piece, the measurement of angle 2, it should equal the whole piece, which is the measurement of angle JKL. So the 2 parts added together equal the whole. Same idea as it was with segment addition. And now I can actually replace what I know from the given information. I know that angle 2 is 56, for example. I don't know what angle 1 is. That's what I'm being asked to solve for. But angle 2 is 56, and that JKL is 145. So now this just becomes a simple algebra problem, if you will. And the measurement of angle 1 is equivalent to 145 minus 56, which in fact is 89. So now we know that the measurement of angle 1 equals 89. So now if you will go ahead and try to do it yourself, number 1, which is right here below, then we will continue. All right. So the next item up for business here is a couple of theorems. I remember that theorems, unlike postulates, theorems do require proof, and so we're not going to prove them right now, but you might find some of the homework will ask you to prove it. We will be proving some of the theorems today, but not all of them because of the interest of time. But these are some theorems that we have here. We have the supplement theorem and the complement theorem. Okay, and the supplement theorem states that if two angles form a linear pair, then they are supplementary angles. Okay, so we have a diagram that represents what's going on here. So you have two angles, angle 1 and 2, they form a linear pair. In other words, the two angles together make up a line, linear, they're a pair too. If that happens, then angle 1 and angle 2 are supplementary. And if they're supplementary, that means that angle 1 plus angle 2 equals 180. And likewise, complement theorem is very similar, only it's dealing with complementary angles. If the non-common sides of two adjacent angles, so we have two adjacent angles, the non-common sides, which are basically this side and that side, if those two sides form a right angle, like they do here from this little red indicator there, then the angles are said to be complementary angles. So again, that would mean that angle 1 plus angle 2 equal 90. So those are our two supplement theorem and complement theorem. Those are tongue twisters. So here we have our next example. Example 2. Using a transit, a surveyor sights top of a hill. I don't know if you guys know what a surveyor is, but it's a person that, sometimes you see them on the roads, they have these little devices, what they call a transit, and they can see things from really far away, and they make measurements and all this good stuff. So here we have my little lame diagram. You can look in the book for a better diagram. But I've got a person here, here's my surveyor, and he sights, so he's basically seeing to the top of the hill, and he records the angle measure to be 73 degrees. So what is the measure of the angle the top of the hill makes with the horizon? So see, we have, this is basically the line of sight there, and so he already measured the angle to be 73 degrees, so we can probably put that information in here. Let's go ahead and do that right now. He measured that angle to be the top of a hill and records an angle measure of about 73 degrees. And then it's asking us, what is the measure of the angle that the top of the hill, so here's the top of the hill, makes with the horizon. So here's your horizon, okay? So they want us to basically find the measurement of angle 2, all right? So we're going to say again, this time we have these two lines, these two segments that are actually adding up to 90. So according to the complement theorem, we know that the measurement of angle 1 plus the measurement of angle 2 should equal 90, because if the two non-adjacent sides of these two angles make a 90-degree angle, which they do, then these two angles are said to be complementary, hence they're supposed to add up to 90. So measurement of angle 1 plus measurement of angle 2 equals 90, and since we already know that the measurement of angle 1 is 73, we can go 73 plus the measurement of angle 2 equals 90, subtract 73 from both sides, and I believe that the measurement of angle 2 equals then 17. So that is how you do that little guy. And so again, on the same board, we have do-it-yourself number 2, a little diagram. So if you will do that in your notes, we will carry on. Our next slide is basically a bunch of properties that you need to write down in your notes. I kind of abbreviated what was on page 153 of your textbook. I didn't draw a lot of the diagrams for these first 3 because we've seen them before. If you want, you can obviously look on page 153 and you can get those diagrams. So we have the reflexive property again, angle 1 congruent to angle 1. The symmetric property, if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. The transitive property, if angle 1 is congruent to angle 2, and in turn angle 2 is congruent to angle 3, then we can get rid of the middleman, which is angle 2, and we can just say that angle 1 is congruent to angle 3. But again, we've seen those before, so but just so you have them. Then we have 2 other theorems, and the first is right here, congruent supplements theorem. And it's not the same thing as the supplement theorem. We saw that a little while ago. There's a supplement theorem and a complement theorem, but this is different because it's called congruent. Oops, we don't want to do that. We want to do congruent. Okay, this is not working. Sorry. There we go. Congruent supplements theorem. So this theorem is a little bit different, so I kind of want to make sure that we go over here. It says that if two angles, basically, angles plural. So if angles supplementary to the same angle or to congruent angles are congruent. Okay, so what we have here is some examples. We have angle 1 and angle 2 are supplementary. See, angle 1, angle 2 equals 180. Also, 2 and 3 equal 180. So they're also supplementary. So we have an angle 2 for example, that is being repeated. So we have angle 1 is angle 1 is supplementary to angle 2, but angle 3 is also supplementary to angle 2. Therefore, angle 1 and angle 3 are congruent. That's what this theorem is saying, okay? So again, angles that are supplementary to the same angle. So angle 1 and angle 3 are two angles that are supplementary to the same angle, which is angle 2. In that case, angle 1 and angle 3 would be congruent. And in a similar fashion, we have congruent complements theorem. Again, not the same as complement theorem, but a congruent complements theorem is the exact same thing, only in this case, we're talking about complementary angles, obviously. So two angles that are complementary to the same angle or to congruent angles are also congruent. So again, we have that 4 and 5 are complementary, they equal 90, but also 5 and 6 equal 90, so they're also complementary. And again, we have that the angles 4 and 6 are complementary to the same angle, which is angle 5, and therefore angle 4 is congruent to angle 6. All right, and so those are some theorems that you need to have in your notebook. And so I'm going to show you an example of how we can prove this theorem. Like I said before, we are going to prove some of this. Is not an example, this is just me proving the theorem. Okay, so what I have here is I've got angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. So what I'm seeing here is that I have two angles, 1 and 3, that are supplementary to the same angle, which is angle 2. Okay, so according to the theorem, angle 1 should be congruent to angle 3. So I'm going to prove it so you can see how these things work. Okay, so I started already with my given statement here. When two angles are supplementary, then that means that we can write that the measurement of angle 1 plus the measurement of angle 2 equals 180. And also, measurement of angle 2 plus measurement of angle 3 equals 180 by definition of supplementary. That's what it means to be supplementary. All right? So then, I'm going to use substitution, or actually you could even use transitive property here. Basically, we're saying that angle 1 plus angle 2 equals 180, and then 180 in turn equals 2 and 3. So therefore, the measurement of angle 1 plus the measurement of angle 2 should equal the measurement of angle 2 plus the measurement of angle 3. So again, I want to show you how that works. Angle 1 plus angle 2 goes to 180. 180 goes to 2 and 3. So we can get rid of the middleman, which is the 180, and just say that 1 plus 2 equals 2 plus 3. And so our reason for that is transitive property. You can also use, in this case, you can use a substitution, because you can replace the 180 with the 2 plus 3. Either way, you get the same step for number 3. And now, since we have an angle 2 on both sides, we can subtract angle 2 from both sides and get the measurement of angle 1 is equal to the measurement of angle 3, and that would be subtraction property. So, not subs, but subtraction property. And then, because angle 1 is equal to angle 3, then angle 1 is congruent to angle 3, which is definition of congruence. And I can put my Helmos here, and I made a 6 step just in case I needed them, but I don't need 6, I only need 5 steps. So there is your proof of the congruent supplements theorem. So now we can just keep using it. So again, I didn't want to, we're not going to prove all of the theorems, but in a very similar fashion, you can prove the congruent complements theorem as well. So right now, we want to do some examples using the congruent complement supplement theorem. All right, so here we go. We have a diagram. It says prove that vertical angles 2 and 4 below are congruent. So we're trying to prove that angle 2 and 4 are congruent. And so it says given angle 2 and angle 4 are vertical angles, and that we can just see from the diagram that they're all, and because it says vertical angles 2 and 4. So we know that angle 2 and angle 4 are vertical angles, and they want us to prove that they're congruent as well. Okay, so we're going to start with step 2 here. Because angle 2 and angle 4 are vertical angles, we can also tell from the diagram that angle 2 and angle 3 form lin pair. I had to abbreviate there. Angle 2 and angle 3 form a linear pair. And you can see that from the diagram. But of course, also we know that 3 and 4. So we have 2 and 3, they form a line. 3 and 4 form a line. So we're also going to state here that angle 3 and angle 4 also form lin pair. And our reason is going to be definition of a linear pair, which we saw the definition for a linear pair in a previous section. So there we go. That's my step 2. But because they're a linear pair, we know from the supplement theorem that angle 2, I'm getting ahead of myself here, angle 2 and angle 3 are supplementary. Angle 3 and angle 4 are supplementary. Okay? And that's from the supplement theorem. So I just want to take you back real quick in case you think I'm lying to you. Oops. I wasn't going back, I was going forward. Sorry. Right here. The supplement theorem. If 2 angles form a linear pair, then they are supplementary. That's the theorem that we're using, the supplement theorem. So we're going to go back to our proof, and we're going to put, supplement theorem. Supplement theorem. All right? So now we know that those two, because they form, those two pairs form linear pairs based on the supplement theorem. And then finally, our last step, we have here that angle 2 and angle 3 are supplementary, and angle 3 and angle 4 are supplementary. So if you remember the previous theorem that we just talked about, we have 2 angles, 2 and 4, 2 different angles that are supplementary to the same angle, primarily angle 3. So when that happens, angle 2 is congruent to angle 4. So our last step, angle 2 is congruent to angle 4 because of the congruent supplements theorem. Not the same theorem as the one before. This was just supplement theorem, but now we're talking about congruent supplement theorem. All right, and that is how you can use that theorem to prove more things. So now we want you to try this little guy, and then we're going to move on to our vertical angles theorem, which, by the way, we just proved. This is a proof of the vertical angles theorem. And so now that we have that theorem, here we have it written down, vertical angles theorem. If 2 angles are vertical angles, then they are congruent. So basically I have a diagram showing you that in this case, because 1 and 3 are vertical angles, then they're congruent. Since 2 and 4 are vertical angles, they're congruent. All right? And then we have our example 4, which is yet another proof. This is our last example. And it says, prove that if ray DB bisects angle ADC, then angle 2 is congruent to angle 3. So the hypothesis is the given statement. So DB bisects, ray DB, bisects angle ADC. And then the conclusion is of what we're being asked to prove. So angle 2 congruent to angle 3. I have a diagram here kind of showing what's going on. And so then we have our proof over here. There are 6 steps, and we're going to go right into it. Let's get some different color here. So again, start with the given. Ray DB bisects angle ADC. That's given. And because ray DB bisects the angle, that tells me that angle, so here's ray DB, and it's bisecting angle ADC. So it's bisecting this angle. It's making these two into two equal parts. So that means that angle 1 is congruent to angle 2 by the definition of angle bisector. Okay? Angle 1 is congruent to angle 2 by definition of angle bisector. Another thing that we can see from our diagram is that angle 1 and angle 3, these two angles, are vertical angles because they form an X. So angle 1 and angle 3 are vertical angles. All right? And that's by definition of vertical angles. I'm abbreviating as much as possible in the interest of time, but there we go. Angle 1 and angle 3 are vertical angles. Well, because we already learned in the previous theorem that when two angles are vertical angles, which is right up here, if two angles are vertical angles, then they are congruent. So that means that angle 1 is congruent to angle 3 by the vertical angles theorem. Yummy. Okay, angle 1 is congruent to angle 3 by the vertical angles theorem. And then we can get our last step pretty much because we wanted to prove angle 2 and angle 3, right? So let's see if we can get that little guy. I think, yes, we can. We can go angle 2 congruent to angle 3 now by the transitive property. Transitive. And I'm going to put that step 2 and 4. If I combine steps 2 and 4, maybe you'll see what I'm talking about. So what I'm seeing here is that 2 goes to 1, and that's in step 2. 2 goes to 1. And then in step 4, 1 goes to 3. So the middleman is angle 1. So if we get rid of angle 1, then 2 goes to 3. And hence the transitive property. Okay, and that is what they asked us to prove, that 2 is congruent to 3. So again, I don't need my 6th step. But I do want my helmets over here. Okay, Ben. Off to the side there. And now I'm done with my proof. Awesome. So now I'm going to have you try this do-it-yourself number 4. This is actually not a proof, but it does require you to be using vertical angles. And then the last thing I want you to do, even though this is the last do-it-yourself question, you do need to write down these right angle theorems. All of these statements are true about right angles. Again, in the interest of time, I didn't draw all the diagrams, but I do have one of them up there. And again, if you want more detail, you can find them on page 155 of your textbook. But basically, these 5 things are that perpendicular lines intersect to form 4 right angles. So angle 1, angle 2, angle 4, and angle 3 are all right angles. Second theorem is that all right angles are automatically congruent. Third one is perpendicular lines form congruent adjacent angles. So angle 1 and 2 are congruent. Angle 2 and 4 are congruent. 3 and 4, 1 and 3. Our fourth statement is if two angles are congruent and supplementary, in other words, they add up to 180 and they're both equal, then they have to be a right angle. That should make sense. If two angles have to add up to 180 and they each have to have the same measure, then obviously each one is 90 and 90. And then likewise, if two congruent angles, our last one is if two congruent angles form a linear pair, that means that they're automatically supplementary, and just as we saw in the previous one, they are right angles. Okay, so those are your right angle theorems. Once you write those down, then you will be done with this lesson, and I will see you in class, and thank you for watching.